So the main thing I wanted to do in this video is just kind of show you the timing of a heartbeat. And we've been drawing the left ventricular pressure, and so far I've kind of just sketched it out. But now I want to try to be a little bit more careful with how I draw it so that you can get a real appreciation for how long everything seems to take. So these numbers I'm going to write up are just estimates. They're not exact numbers. And of course, you know that many things change how fast or slow a heartbeat can be, but they give you a real sense for the timing. So let's get started. The left ventricle, it begins, we know, with a pretty low pressure, right? Pretty low pressure. Let's say this is about 50 millimeters of mercury. I'm just going to estimate this is about 10. And we know that it's going to begin contracting, and I have to pick a point somewhere, so I'm just going to kind of pick this point right here. It begins contracting at a pretty low pressure, about 10 millimeters of mercury, let's say. And right before it contracts, the last kind of thing that happens, remember, is atrial systole. And it's kind of a lump in the pressure. Kind of the pressure goes up and then it kind of slightly goes down. And that's because of the atria contracting, right? And before that, I'm kind of going backwards now, you see that? Before that, the atria and the ventricle are just kind of slowly filling up with blood. And so the pressure is just kind of slowly creeping up. So that's kind of the first step in terms of what the left ventricle pressure looks like. It kind of creeps up and then has that little bump in the end. Now it has to go from that point to a very high point, right? When the ventricle contracts, it's going to skyrocket in pressure. Let's say it's going to get up to around 80 or so. And it doesn't take much time. It actually does it all in about 0.05 seconds. It kind of just shoots up like that. So it kind of just skyrockets up. So that's the next step, right? It kind of rockets up. And really, let's talk about these 2 points real quickly. These points here, let's call this B and I'll call this A. And so between A and B, what's happening exactly? Well, A, the big kind of event at A is that the mitral valve closed. So I'm going to write mitral closed. And then, of course, at B, the big event is that the aortic valve opened, right? So I'm going to write aortic opened. And you know when I write aortic, I mean the valve, not the artery, because, of course, the aorta is just an artery. It's always open. But the aortic valve opened at that point. Now, between those two, and this is actually really kind of cool thing to think about, between those two, what's going on? Well, here, when the mitral valve closes to the point where the other one opens, you've got a chamber, the left ventricle, with kind of like a room with two doors that are closed, right? There's nothing open between these two spots where I've drawn the red. And so because all of it's closed, we actually have a special name for this because there's contraction going on, right? The left ventricle is contracting, so we call that contraction. But because there's a room with two doors closed, the blood has nowhere to go, right? So the volume of blood is not going to change. It's going to be the same. And the kind of medical word for that is iso. Iso means same. So isovolumetric, same volume, isovolumetric, so contraction. And all that means is that, hey, the left ventricle is contracting, and oh, by the way, the blood volume is not changing because there's nowhere for the blood to go. So kind of a fancy word, but that's what it means. So now the blood is going to start entering the aorta up here. And it's going to really get kind of a high pressure, right? And we know that it's going to take a little bit of time for all that blood to go into the aorta. In fact, it takes about 1/4 of a second. And at the end of it, we know that the pressure has to be, or is going to be, somewhere around 100. So it's going to be around 100, but my blood pressure is going to peak out somewhere higher than that, somewhere around 120. In fact, I know that because whenever I go to the doctors, they always check my blood pressure, and they tell me, hey, Rishi, your blood pressure is around 120/80. So this is helping me draw my graph, right? So I can say, well, I know it has to get up to about 120 because that's what my doctor told me it was. And at some point, it's going to kind of dip down again to this point. And I'm drawing it at 100 because we know that the aortic valve is going to close at some point. And then, of course, you remember that whole dicrotic notch bit. But that's kind of roughly what it might look like. In fact, let me actually just draw that with a yellow. And the yellow just kind of reminds us that now, at this point, blood is entering the aorta. So whenever this whole yellow bit is blood going into the aorta. And of course, you get to another important spot here. And you remember, let's call this spot C. Here, the aortic valve closes. So this is where the valve now kind of says, hey, enough is enough, let's shut down, because pressure is kind of going the other way. And then our blood pressure is going to fall, right? It's going to fall, and it's going to fall over a bit of time. It's actually going to take about 0.15 seconds, and it's going to go to about, let's say, I'm just kind of sketching it out, let's say about here. So about that point, let's say, and it's going to fall, 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 fall. And why did I choose this point? Well, that's the point where we say, well, this is where, what happens? What happens at this point? The mitral valve opens, right? The mitral valve opens that spot. And then, of course, the pressure continues to fall, right? It gets pretty low, and then eventually it has to kind of get back up to where we started, right? Otherwise, the next heartbeat is not ready to go. So we have to kind of creep our way back up as the blood kind of fills in, and we're done. So this part right here, this third segment, where I'm going to kind of use green, again, you have the aortic valve is closed, but the mitral has not yet opened, right? And so does blood have anywhere to go? Nope. It's stuck in a room. So if the blood is stuck in the left ventricle and the left ventricle is relaxing, then you better believe we're going to have a fancy word for it. We're going to call that relaxation. I guess not that fancy. But the first part of it is iso, same, volumetric. So same volume, isovolumetric relaxation. And that's this part right here. Because again, the blood has nowhere to go and the left ventricle is relaxing. And the last chunk out here, I'm going to do in kind of a different color, blue, let's say, is where blood is slowly kind of just filling back into the left atrium, and obviously since the mitral valve is open, also the left ventricle. So these are the four kind of segments, right? And you might think, well, wait a second, what about that first segment? I didn't color that part in. And what I'm going to do instead is I'm going to say, well, this was about, let's say this was 0.2, right? So I'm going to do the same thing over here. I'm going to say, okay, what about the 0.1, 0.2, right? That would be equivalent, right? I'm going to say blood pressure keeps rising, and let's say we have our little atrial systole, something like that. So just to make it kind of continuous instead of kind of drawing two separate chunks, I think this will prove to you that it's basically the same thing, right? So this is kind of getting ready for the next heartbeat, but in terms of time, you would agree that that's the same segment. So then if I was to actually chunk it out, this part right here, I'm just going to kind of draw it on the timeline axis, is about 0.5 seconds. So this is about, I'm going to try to draw it big. I said 0.5, sorry, 0.05 seconds. My mistake, sorry. So 0.05 seconds. The next chunk, right, this bit right here, is about 0.25 seconds. So you could say about a quarter of a second is right there. This is about a quarter of a second. And then you've got the next chunk. This is about 0.15 seconds. And again, these numbers are not super important, but I just want you to get a rough sense of kind of simply the fact that this is actually not the same as the contraction bit, right? So it's a little bit longer to relax. So just kind of get that intuitive feel for that. And then finally, this last bit, this is kind of obviously the longest bit, right? This is just going on and on and on. This is going to be about holy cow, it's long, huh? This is about 0.55 seconds. And of course, if you add up these four numbers, if you add them all up, they should add up to 1, right? 1 second. Because the whole point is that this is all happening in about a second. And that's if we assume, of course, that our heart rate is 60 beats a minute. Now that is not always true, of course, right? Certainly sometimes it's much faster than that. But if we assume that, just for the sake of kind of getting a sense for, a feel for this stuff, then this might be a rough estimate of how it might look, right? Now, one thing that I've always thought is kind of interesting, when you look at this stuff, you think, okay, well, which parts are systole and which parts are diastole? And these two, if you chunk them together, if you add them up, this makes up your systole. So that's kind of a nice way of thinking about it. And if you then add up the rest of it, this whole bit right here, this is your diastole. And you remember we have talked about how the fact that diastole is about 2/3 of the time and systole is about 1/3 of the time. And you can see how that's basically true here, right? And now the final thing, this is actually something that kind of always threw me off, kind of confused me a little bit, is this chunk right here. This chunk, I've always wondered why this isn't part of systole. You know, it certainly looks like it's part of the lump, right? Or the big mountain kind of drawing. But the truth is that we have to remember that the left ventricle is relaxing during this time, and diastole is all about relaxation for the left ventricle. So because it's part of relaxation, it is technically and truthfully part of diastole, even though it looks like it's part of the lump. So just keep that in mind.